Hello and welcome to my video, lesson 4.8 on perfect square trinomials. So to begin with, perfect squares are 1, 4, 9, 16, etc. all the way to 100. Those are ones you should know about, but there are infinite perfect squares. You could keep going forever. What makes them a perfect square? Well, it's because they can be expressed as a product of two identical terms. So for example, 25 is a perfect square because 5 times 5 is 25. So therefore, 25 is a perfect square. I do want to also point out before we continue that negative 5 times negative 5 also equals 25. So just keep that in mind as we continue. So why is it called a perfect square? Well, it's because squares have equal width and length. So you square the side length to find the area. So 5 times 5 is 25. Or you can write it like this. A square symbol, right? Same holds true for polynomials. So just keep in mind that fact, and I'll just write this above, that you could write this like this, and it would be perfectly valid. In fact, it would be lovely if you wrote it with a little squared above. Now, notice that if we expand this polynomial, what do we get? We would get, and I'll spend a little bit of time on this one, and then maybe speed things up as we go, because expanding at this point should be a little bit faster, but we should get something like this, and you'll notice that we're going to add these two middle terms together, so we get x squared plus 2x plus 1. All right, that's pretty easy. Let's continue on and expand all of the following to see what perfect square polynomials will look like. I highly recommend that at this point you pause the video, expand them, and see if your expanding skills are up to par. Otherwise, you may need to go back and watch that video to help you out. Okay, so I'm just going to write down the answers quickly here. X squared plus 4x plus 4. This is x squared minus 6x plus 9. This is x squared minus 8x plus 16. This is 4x squared. Okay, this is actually I'm going to spend a little bit more time on this one. 4x squared plus 10x plus 10x plus 25. So when we put it together, we get 4x squared plus 20x plus 25. Okay, and then here, similar sort of thing. X squared, 6 minus 12x plus 4, I believe it is. Yes. So those are the different numbers. Okay, what do you see as a pattern for the above numbers? And keep in mind that we also had the previous example from the one above here. What's the pattern? Well, I hope that you notice that the last number in all of them is a perfect square. Okay, so that's a really good pattern. You can also notice that in order to go backwards, I'm just, sorry, not changing that color. In order to go backwards, if you square root this, it gives 2. And then if you double it, it gives 4. So square root, it gives 3. Double it, it gives, 6. So why is it negative 6? Well, because if you look back over here, I mentioned that negative 5 times negative 5 gives a positive value. So when you square root it, you're actually getting a positive or a negative value. Okay, so there's a little bit to it here that you can kind of see going this direction. It's even more clear if you go in this direction. So you go like that, you get this, if you like half it, okay, so you take negative 8 divided by 2, you get negative 4, then square it, and you get the 16. Notice, this is beautiful, notice this negative 4 is the negative 4 that's inside the brackets. Okay, let's do it again here, and just notice that we get a 1, and then you square it, you get a 1. Notice that this 1 here is the same one that is inside the brackets. So again, it's the same. Okay, these other ones are a little bit more tricky. Okay, you have to, I believe, divide by the number, I think you have to take the square root here, so you get 3. Divide by the square root, so you get negative 4. Then divide by 2, which gives negative 2. And then square it, and you get the 4. So it's a little bit more convoluted, but you might be able to see this pattern working here as well. So square root, so you get 2. So here we're going to divide by 2, we get 10. Then we divide by 2 again, we get 5. Then you square it, and you get 25. So a little bit convoluted, but you can see there's still a pattern here. It's just that the first number affects it and makes it kind of wonky, which is, PSA 2 is kind of what's happening here. Okay, now this whole lesson may seem useless, but this is a very useful lesson when it comes to completing the square, which is something you do in the 20 level. So just keep this in mind. This is useful moving forward. It's not as important in the 10C, but it will be useful next year. Okay, let's continue on. Here are some example questions. Which of the following are perfect square trinomials? Well, what you can do is check by dividing this by 2 and then squaring it, and it gives 49. So this one is a perfect square. This one, you divide it, you square it, and it gives you positive 16, not negative. So the negative here will never be a perfect square. If there's a negative for the last term, it will never be a perfect square trinomial. Okay, let's try these 4 examples, and then I would recommend after this pausing the video. Oh, what happened? Oh, it deleted some of my stuff here. Just hold on a second. I bet you it did it for the other ones as well. Yes, it did. There you go. Yeah, it did it over here as well. Just give me a second as I change stuff around. Okay, perfect. So find all integers that could replace the box in order for it to be a perfect square trinomial. Well, here we'd have to square root 4 to get 2, then double it to get 4. Now, the thing is that there it says all that could replace. So yes, a 4 works, but a negative 4 also works. So hear me out. This could be written like this, or it could be written like this. Both are valid. I should say that the box seems to be coming after a positive, but it's asking all integers, so it'd be like this. More precisely, it would be written like this. But that's the same thing. So both of these are perfect square trinomials, so be careful. All integers includes both values. Okay, let's take a look at these next ones here. We've got the same sort of thing happening, square root of 64, and we get 8, then we double it, and we get 16. So 16 seems like a good answer, but also negative 16. All right. Let's try these next ones here. What you're going to do is, if we're going the other direction, we half it, then we square it, and we get a 1, and there is no positive or negative version, it's just positive 1. Half it, square it, and you get 121. And yeah, I believe that's about it. Okay, so here are some practice questions. I suggest you pause the video here, try them out. Okay, then you can pause the video here. You'll see these last two questions as well. Try them out. Okay, and now I'm going to try these questions. Okay, so which of the following are perfect square trinomials? Well, we just try dividing by 2 and squaring it. And it does give 36, so it is. So this one, we divide by 2 and square it, and it gives 25. So even though 100 is a perfect square, this trinomial is not a perfect square. All right, last 4 questions. If you need to pause it here, now's your chance. Okay, so we're working backwards, so we're going to take the square root of 81, which gives plus or minus 9. So that means our answer, when we double it, is going to be plus or minus 18. Okay, we're going to do the same thing over here, square root of 144, which gives us plus or minus 12. So when we double it, that means we're going to get plus or minus 24. Okay, looking the other way, if we take 6 and divide by 2, we get 3. We square that and we get 9, and that's our final answer. This one, we take this number and we divide by 2, and then square it, so we get 25. Okay, and just an aside to this, if we wanted to get the actual, like if it said also factor, the result would be a perfectly legitimate question, or part B to this. It would be really easy because we've already done all the work. So all we would have to do is use this value, and we'd write x plus 3, x plus 3. Over here we'd write x minus 5, x minus 5. We've already done all the work, so it's really easy. Okay, so if you want to pause it and try doing that same thing for these two, factor the result. Okay, again, it's pretty easy. You just take the number, so it's x minus 1, x minus 1. Here we have 11, so it is x plus 11, x plus 11. So if you're factoring these, you might now be able to factor them much faster than using regular PSA, because you can just see that it's right away a perfect square trinomial. I hope this video helps you better understand these perfect square trinomials, and good luck.